Hello there, and welcome to today's class. For today's class, we're looking at the physics practical experiment L2 solution. All right, so this is experiment L2. Experiment L2 is an experiment on the refraction at plane surface 2. All right, so L1 deals with the refraction at plane surface 1, while L2 talks about the refraction at plane surface 2. Okay, so the aim of this experiment, the aim is to verify Snell's law using parallel sided glass block. All right, so you have your apparatus and all of this setup. Okay, now for this video lesson, I'm just going to show you how you can fill up the practical manual. All right, so this practical will be done in the lab. I'll just focus more on how to fill up the manual. All right, so let's go to the question aspect or this question part. All right, so let's go to the question part. All right. So after your practical, you'll be asked to fill in the results aspect, which is this. Now, from what you have here, from this table here, you have I, which is your angle of incidence. You have R, which is your angle of refraction. You have sine I. You also have sine R. Okay. Now, when you're done with the practical, you observe that the values of R will be given. Okay. So after the practicals, you'd have to get the values of R from the practical. Then when you're done, to get sine I, just simply punch sine of I. That means to fill up this column here, right? Just take sine of I. For instance, this will become sine of, for the first one here, I is 20, so it becomes sine of 20, such that if I punch sine 20, what I'll have is 0.34. So this becomes 0.34. So here would be 0.34. That will be the value. So just like that, punch sine 30, write your answer here. Punch sine 40, write your answer here. So that's how you fill up this sine I column. Also, for your values of R, okay? So let's say you had your values of R. Let's say at this point, you got your answer here as, let's say you had 12 here, okay? So to get sine R, you simply punch sine of, you take the R column, which is the angle of refraction. So it becomes sine of 12, which if I punch sine 12, what I'll have is 0.21. So you have 0.21 here. All right, so just take sine of each of these values here, use it to fill up this one here. Okay, now I've already done this, so I'll just give you my own values. Please, if you're watching this video, just take it as a step-by-step guide to fill yours. Do not copy my answer. All right, don't change your own answer. Just follow my process here to fill yours. Okay, all right, so let me take you to my table so you see what it looks like. Right, so this is what, of course, this was given to me by one of the students. So I use this value, their value, to fill this. It does not mean that this is the most accurate, no. But then I believe that by now you should be able to fill up the value of sine I and sine R. So what I got 0.34 by punching sine 20. Sine 20 gives you 0.34, sine 70 gives you 0.94. For your sine R values, sine 12 gives you 0.21, sine 17 gives you 0.29, sine 32 gives you 0.53, sine 40 gives you 0.64. So this is how you fill up the table. That's your first task. All right, let's go to the next task there. So having done that, the next task is to state Snell's law and draw a suitable graph to deduce the refractive index of the glass block N. So first things first, let's state Snell's law. What does Snell's law state? All right. Snell's law states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given medium. So this is Snell's law. So we've done this part. The next one says you plot a graph. Let's go back to the question again. Right, it says, and draw a suitable graph to deduce the refractive index of the glass block. Now, here's the thing. If you ask to plot a graph, usually it should be something like plot a graph of, let's say, A against or A versus B, right? So how come they're not giving us something versus something? So if I'm to plot a graph, what should I plot against what? That's the question. Because on a normal physics graph, you'll be given plots, let's say A versus B or A against B. But in this case, you were not told. So how do you know what to plot? Well, the idea is here. They said to deduce the refractive index of a glass block. And from Snell's law, we said refractive index N is equal to what there? Sine I all over sine R. So if this is how I can get my refractive index from Snell's law, it means this becomes my Y all over my X. In essence, I will be plotting sine of I to or against sine of R. So on the vertical axis, which is the y-axis, you plot the sine I values, okay? While on the horizontal axis, which is like the x-axis, you plot the sine R value. All right. So back to my what's it called? Back to my table of values. All right. So I have this table of values here. So back to my table of values. Let's plot this on a graph and see what we get. All right. All right. So let's get a graph for this. All right, so I've finished plotting this. So you can see what my graph looks like. So this is what I have as the graph for this one here. Now, don't forget every graph must have two things there, which are what and what there, the title and the scale. So for this one here, the title of this title is simply the graph of, now I plotted sine I versus, okay, I can use versus or against. Let me just use versus. So versus sine R. So I have this. All right. So this is the title of the graph. All right. Sine I. Don't forget sine I. We said will be on the here on the vertical axis. Y sine R will be on the horizontal axis. So I have this. After title, you have another important thing that you should include in your graph, which is what there, the scale. So I'm taking this off so I can write my scale. All right. So scale used. The next thing you should write there is your scale used. For my scale use, what do I have here? For this, if I look at this, if you look at this carefully. Now, from this point, here's my origin. From the origin to this point is called 1 unit. Okay, so I'll say let 1 unit represent, let 1 unit represent what? Now, if I look at this, from here to here is about 0.1. That's on the sine I axis. Also, from here to here, just 1 is about 0.1. So if I move one step, I'm having 0.1 on the sine I axis. If I move one step, I'm also having 0.1 on the sine arrow axis. In other words, 1 unit will represent 0.1 on both sine I and sine arrow axis. All right, so this is how you use your scale. Let 1 unit represent 0.1 on both sine I, you can say sine I axis and sine arrow axis. So this is how we do the scale used. All right. Now I'm using this because I'm using a software to do this. Okay. So if you plot your graph and it's not exactly like this, you should know how to um, go about your scale. Okay. All right. Next up. So having gotten our title and scale, what next? We have to get what is called the we have to find the slope. Let's see. So back to the question. All right, so they said enjoy a suitable graph to deduce the refractive index of the glass block. All right, so let's deduce the refractive index of the glass block. So how do we do that? Now, to get your refractive index of the glass block, don't forget that from Snell's law, we said N is equal to sine I all over sine R. And in this concept, we can get sine I over sine R by taking the slope of this graph. Okay. Now, from this, if you can see this part here, from this, the software gives you what's it called? The slope here. From here, I can see that my slope here is about 1.43. All right. So it has already calculated it for me. So, but you calculate your own slope from your graph. Just for reference, or just to show you how it's done, let me show you how you get a slope. So let's say when it comes to getting slope, right? If you look at this, I have this line running vertically like this. I also have lines this way, going horizontally like this, right? So look out for that point where this line, this red line you're seeing here, right? Look out for that point where this line cuts through like this. Look out for this point here where it cuts. For mine, it's not very perfect because I'm still using a software, but then let me show you something. So for me, I would choose somewhere like here. So if you look at this point here, look at this point here, it's as if it's touching, or should we come down a bit? Okay, so look, this one is good. So if I look at this, it's as if this line here, this slanted line, is cutting through the horizontal and the vertical. So I'll pick up this point here. If I also go down, something around, let's assume here it's also like that. So I'm taking here. All right. Your next task will now be trace this line like this, trace it horizontally. This one to trace this vertically. So I have this. All right. So my slope, how do you calculate your slope? The slope would be equal to change in the parameter on the y-axis, which is sine I, all over change in the parameter on the horizontal axis, which is what there, r. So I have this, and this is equal to, your formula is sine I1 or I2, please, excuse me, becomes sine I2 minus sine I1 all over sine R2 minus sine R1. So I have this. So how do I get the value of sine I1, sine I2, sine R1, and sine R2? Okay, taking this off again. Let's pick out value. Now, by the way, in this case, your slope is actually n. So n is equal to sine I2 is simply this value here. This top one you have here, trace this way. If I trace this point, you can see it's about 1.2 minus sine I1 is from here. I will trace this way, which is about 0.5 all over sine R2 from here. Trace this down. If I trace this down, it's about 0.8 here. So 0.8 minus sine R1 from this point here. Trace this one downwards like this. And I'm having here about 0.3. So 0.3. So I'll just get my calculator and punch this. So if I punch 1.2 minus 0.5, I'm having here as 0.7 all over 0.8 minus 0.3 should be about 0.5. Alright, so if I punch this will give me about 1.4, which is still close. Now remember that the software said the slope is about 1.43 and I'm having 1.4. I'm having 1.4 because if you look at this, as I said earlier, this was not too accurate. We just assumed it. I was just trying to show you how you get your slope. Alright, but I'm still going to go with this value here, this value of the 1.43 as my slope. Alright, so back to our work. Alright, so from here, state Snell's law. The Snell's law should be written here. Alright, so now you say Snell's law states that the sine of the angle of incidence to the sine of the angle of refraction is a constant for any given medium. It should be written here. Now, you also asked to deduce the refractive index. That should be done on your worksheet, right? So after the graph, there's usually a worksheet where you should do that. All right, so just state Snell's law at this point here. I've already given that one before now. All right, so I think this one is done. We've also gotten the value of n, which was the slope. So this I is done. Let's go to II. II says, what are the precautions you took in this experiment? So you write the precautions here. So let me give you some of the precautions. Now, in this one, they didn't specify how many you should list. So if you can list up to like 3 or 4 or 2, but I would advise you list about 3 if possible, okay? All right, so let's look at some of the precautions you took in this experiment. What should be your answer? All right, precautions. Number 1, I ensured that the pins were evenly spaced at 5 centimeters apart. Now, why did we use 5 centimeters apart? If you go back to the question, let me take you back to the question. or to the first page. So this was like the first page. If you look at the first page, there's an instruction here. Number 4 says, then put the optical pins at P and Q at exactly 5 cm apart. So the 5 cm was actually an instruction that was given. All right, so I'm just stating this again. This is how I got the 5 cm. All right, so back to this. I ensured that the pins were evenly spaced at 5 cm apart. That's one. Number 2, you can say I avoided error due to parallax by looking directly at the protractor while taking the while reading the angles. That's also a precaution. Number 3 says I ensured the dimensions of the rectangular glass prism was correctly traced. That's also a precaution. Number 4 says I ensured I placed the pins in line with the first two pins while looking through the rectangular prism. So these are like the precautions you can write there. So I've said if possible write like 3 precautions. You don't have to write the 4, no. Or you can even look for yours. All right. So these are like some precautions you should take. All right, so next question. Next question number 3 says list the possible sources of error. Again, in this one here, observe that they didn't ask you they didn't tell you the number of sources you should list. All right, so list as many as you can. So what are the possible sources of error in this experiment? Let's check them up. All right, so I'm giving you 3 possible sources of error. The first one is instrument error from improper calibration of the protractor. So if the protractor is not properly calibrated, by calibrated I mean, there are lines on a protractor. Let me see if I can sketch this for you. If you have a protractor this way, used to measure angles like this. So usually you have lines running like this. You have lines going like this from which you read the angles. All right, so if these lines are not properly done, you have an improper calibration of the protractor, and that can give you an error. Okay, the second possible source of error is parallax error. That's when you don't read when you don't take your reading by looking directly downwards or towards it. If you take your reading from the side, you have a parallax error. So this is the second possible source. The third one is incorrect measurement of the angle of incidence or refraction, which is personal error. So these are like the possible sources of error. Okay. Now back to the question. All right, we've done so far so good. We've done number 1. We've also done number 2, the precautions. We've done number 3, the possible sources of error. Now finally number 4 says compute the standard error in n. So how do we get the standard error in n? Now, here's how to go about this. First things first, go back to your table of values. Now, here's my table of values. Now, for this now, I would focus only on the sine I and sine R. That's this. So if I take sine I over sine R for the first one, let's say I'm taking for the first one here, this first row here. So sine I all over sine R would be equal to sine I here is 0.34. So 0.34 all over sine R for this first row is 0.21. If I punch it, 0.34 divided by 0.21, I'll have this as 1.62 approximately. Get for the second row. For the second row, sine I, which is this, I have 0.50 all over my sine R here is 0.29. So 0.50 divided by 0.29, that's about 1.72. So do the same thing for all of this, all right? Get the value of sine I over sine R for each of them. Now, when you're done, what's next? Look for the maximum of all of them and also the minimum. Now, what do I mean? Okay, better let me just do everything at once so you get it. Let's go for the third one. We've gotten for the first, the second. Let's go for the third one. For the third one here, I have this one here, which is 0.64. Okay, so that's equal to 0.64 all over this one here, which is 0.42. If I punch that 0.64 divided by 0.42 is about 1.52. Okay, next up, the fourth one, which is this rule. This is the fourth rule, this one here. Let me call this 4. Sine I is this value here, 0.77 all over sine R is 0.48. So 0.77 divided by 0.48, I have 1.60. Okay, next up, if I take this one here, the fifth row, I have 0.87 divided by 0.53. So 0.87 divided by 0.53, I have about 1.64 as my answer. Now, finally, finally the sixth row, I have 0.94. So 0.94 divided by 0.64. 0.94 divided by 0.64, that's about 1.47. So for all of these values, I have about 6 values here. 1, 1, 2, 3, 4, 5, 6. So out of these 6 values here, I'll look for the maximum of them all. If I look at this, the maximum is this one here. This is your maximum, 0.1.72. This is your maximum. Also get the minimum from this. My minimum is about 1. Should be this one here, 1.47. So you use these two values in calculating standard error, right? The maximum of your value for sine I over sine R, and also the minimum. So I'll use this in calculating my standard error. So let's get the standard error. Let's get the standard error formula. So IV there for standard error, the formula is this. Formula is that the standard error in N is equal to, by the way, your abbreviation is SM, is equal to the maximum value of N. So maximum value of N minus the minimum value of N. Okay, so maximum value of N minus minimum value of N, all divided by N. Now the N here is simply the number of points we are given. By points I mean intervals, which is 6. All right, 6. Let's check this up. So if I look, as I have 20, that's 1, 30, that's 2, 40, that's 3, 50, that's 4, 60, that's 5, 70, that's 6. So I'm giving 6 intervals, and that's why I have 6 here. All right, so number of intervals here, that's 6. Now the maximum value of R, as we had, was 1.72. So it becomes 1.72 minus the minimum value of N, as we had, was 1.47. So 1.72 minus 1.47, all divided by N, which was what there? 6. So if you punch this, you should have about 0.04 as your answer. All right, 1.72 minus 1.47 all over 6. That's approximately 0.04 as your answer. So in essence, we can say that therefore the standard error in N is equal to, now we know that N means refractive index, right? And the refractive index for a glass is a constant whose value is 1.5. So 1.5 plus or minus, you now bring back your value of the standard error, which is 0.04. Then in brackets, limits, right? Limits SE. Now limit SE simply means limit standard error. All right, guys, so this is how you answer the physics practical manual questions. All right, so please, if you enjoyed this video, please don't forget to like. All right, please like the video. It helps the channel to grow. Okay, also, if it's your first time, please subscribe to this channel for more content. Also, please leave a comment in the comment section. Right, leave a comment right? Tell us if you enjoyed the video and also suggest other practicals you'd want us to do. And finally, please don't forget to share this to your friends so that they can also learn. Okay, you can check out my course on organic chemistry and my other courses on my website. Simply visit www.jonahemmanuel.com. All right, then you can just create an account, then check either the book section or the courses section, and then get either a book or a course for yourself. Thank you so much and see you in our next class.